Hi guys, so today we're going to work on evaluating functions. We have quite a few of these problems to go through, but they're pretty small and quick, so shouldn't take long. So this says to express each relation as a table, graph, and mapping diagram. Remember, this is going to be what is on your quiz tomorrow. So make sure that you listen closely and practice. So the first one is a table. So here are our ordered pairs, and like I was saying, guys, just so that you're in the habit of doing it, I want you to highlight the x values, okay? Okay. So now we're going to put each ordered pair individually inside this table. So the first one is -1 and -1. So the x goes on the left and the y goes on the right. And then we have +1, +1, +2, +1, and 3, 2. Okay. Now we're going to graph these. So I'm not going to write the numbers on here, but I am. It's hard to tell on this graph where the y and x axes are. I'm just going to lightly highlight them. That helps me to see it better. Okay. Remember, when you're graphing, the first number always goes on the x-axis, and you always do the x-axis first. For instance, here I'm going to go to -1 first. So here's 0 in the middle. So -1 is right here to the left. So on the x-axis, -1, and then go to -1 on the y-axis. Okay, next is +1, +1. So go to the x-axis, +1, and then +1 on the y-axis. +2, +1, x-axis 2, y-axis 1, +3 on the x-axis, and +2 on the y-axis. Okay, it looks like this is a function. There's no x value that is repeating. So now we're going to put it in a mapping diagram. So remember, on a mapping diagram, your domain goes on the left and your range, or your y's, go on the right. So I'm just going to put the numbers that I highlighted, my x's, in the left bubble, making sure that I don't repeat any numbers. So I have -1, +1, 2, and 3. Now none of those repeated, so I did have to write them all in there. If they do repeat, then you just put the number one time. So like for y, I have a -1, a +1, and then I have another +1, but in a mapping diagram, you only need to write it once. Okay, +1 and then +2. And then you can do your arrows. So the arrows are showing you from the ordered pair which two numbers go together. So like the first ordered pair is -1, -1. So you draw an arrow from -1 to -1. And the next is +1, +1. So you draw an arrow from +1 to +1. The next is 2, 1. So draw an arrow from 2 to 1. And then 3 and 2. Okay. And then the last part is the domain and range. And like I was saying in the last video, it's really easy to get the domain and range from the mapping diagram because you already did it. So the domain is just the x numbers. So -1, 1, 2, and 3. Yeah. You could get it from the ordered pair too, but I just like to take it from the mapping diagram if I have that available. So my range is -1, +1, and 2. Okay, next one. Let's go ahead and put it in the table. Oh, let's highlight our x's first. 0, -4, -2, and 4. Okay, so 0, 4, -4, -4, -2, 3, and 4, 0. And again, I'm going to highlight my axes just to make it easier on my eyes. Okay. Remember, the first number goes on the x-axis. So 0, 4, you go to 0 on the x-axis and 4 on the y. -4, -4, x-axis first, -4, and then negative 4 on the y. Okay, negative 2, positive 3 here. And then positive 4, 0, go to the x-axis first. 1, 2, 3, 4, that's here. Okay, looks like this one is also a function. None of my x values are repeating. These are both just relations. All right, now let's do our mapping. My x values are 0, negative 4, negative 2, and 4. And then I have a 4, negative 4, 3, and 0. So these are all just going to connect with an arrow. So 0 to 4, negative 4 to negative 4, negative 2 to positive 3, and then 4 to 0. That one's a super simple one. Okay, and again, my domain is just my x values. You can put them in order from least to greatest if you want to, but I didn't. You don't have to. 4, negative 4, 3, and 0. Okay, so that was just practice with the 4 representations. And then now we go to page 10. And we're going to do the top. So, okay. It says determine whether each relation is a function and explain your answer. So here's where you definitely need to get your highlighter to look at your x values in your sets of ordered pairs. So here I have a 7, a 6, and a 5. None of those x values are repeated, so yes, this is a function. The reason why it is a function is because no x values are repeating. Okay? B is, we have a negative 15 with 0 and a negative 15 with a negative 2. So since this x value is being repeated twice, this is not a function. That's what makes a function. A function, every x value has to have one y value only. So like this one, this x value is with 2, and you can't have that in a function. So this would not be a function since the x is repeated. So you would say the x value 15 is repeating. Okay? And for C, 0, 2, and 0. Again, this is not a function because the x value 0 is repeating. It's not enough to say 0 is repeating. In your explanation, you really need to be specific and say that it's because it's an x value, not just because it's a 0, not just because you have a repeating number. Specifically say because the x value 0 is repeating. That's important. Okay, so these down here, 1, 2, and 3, you don't have to explain. You just need to say yes or no. So we highlight our x values, negative 1, 0, 1, and 2. None of those are repeating, so yes, it is a function. Negative 5, 5, 0, and 3. None of those are repeating, so yes, it is a function. Negative 2, 6, negative 2, and 0. This one is not a function because negative 2 is repeating. So that one's not a function. Okay, last ones were graphs. Go to page 11. Okay, we already did the first one together in class, but we'll just look at it again. So determine whether each relation is a function. You need to use the vertical line test. So we're going to look at our shapes that are on our graph, and we're going to see, is there any spot on the shape where a vertical line will pass through more than once. So I'm just going to draw some vertical lines. I don't see anywhere on this graph where the vertical line would cross more than one time. So this is a function. The answer is yes. And so circle yes, it is a function. And it passed the vertical line test. So that means it is a function. Okay, number 11. I'm just going to draw one vertical line here. And I'm going to show you. Look how many times this vertical line passed through the graph. So at the top, there's 1, 2, 3, 4, 5, 6 times. So this is definitely not a function. It fails the vertical line test. It's not a function. The answer is no. It fails. Okay, for number 12, let's do some vertical lines. Okay, only passes once there, once there, once there, once there. And again, we're only looking at this line that's been graphed. The x and y axis do not count as part of our graph. Once there, once there, once there. Okay, so there's nowhere on this graph that it passes through twice. So the answer is yes, it is a function. It passed the vertical line test. Okay, number 13. Let's draw our vertical lines. One pass, one pass, one pass. We did this one in class. Oh, the one that looked like this in class. This is a function because there's no vertical line that passes through twice. It passed. Okay, number 14. I'm just only going to draw one vertical line because that one right there that I'm drawing passes through the circle 2 times. So that means that no, this is not a function. It fails the vertical line test. Okay, same with number 15. It doesn't matter where you draw a vertical line on this graph, it's going to hit twice. So that means it fails the vertical line test and it's not a function. Okay, so I hope this helped. This is what your quiz is going to be over tomorrow. So make sure to look back over it, and I will see you guys then.